How might researchers avoid or manage this issue when working with delicate or heat-sensitive samples using laser-based Raman systems? In what ways does Raman spectroscopy offer access to molecular vibrations that are not as easily detected by IR spectroscopy? Could it be that certain molecular bonds absorb weakly in IR but strongly in Raman? And why is this contrast important? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What kinds of functional groups fall into this category? Are there specific examples such as S bonds, C bonds, C equals C double bonds, or N equals N bonds that are typically weak in IR but produce strong signals in Raman spectra? How does this selective sensitivity allow Raman spectroscopy to detect important chemical groups that might otherwise go unnoticed in IR measurements? What does it mean that Raman spectroscopy has a wide measurement range, especially in the low wave number region starting from around 25 cm superscript 1? And why is this low frequency sensitivity useful for studying atomic vibrations? Could it be that this low wave number capability provides crucial insight into the behavior of heavy atoms or metal ligand vibrations in complex materials? Why is this ability to capture low frequency modes particularly valuable in solid state physics, material science, or the study of crystalline lattices and inorganic structures? How does Raman spectroscopy perform in aqueous environments, and what makes it particularly suitable for studying systems where water is present? Could it be because water produces extremely weak Raman scattering, thus minimizing interference in the analysis? Why is this low water background such a major advantage for analyzing biological macromolecules, such as proteins, DNA, or other biomaterials, in their natural hydrated state? In contrast to IR spectroscopy, which can be strongly affected by water absorption, how does Raman's insensitivity to water enhance its usefulness in biochemical or medical research? How does Raman spectroscopy offer better resolution than IR spectroscopy in certain cases? Does it allow researchers to distinguish between closely spaced spectral peaks or identify subtle differences in molecular vibrations more clearly? What kinds of experimental results or molecular details benefit from this higher resolution? And how might this influence the choice of spectroscopy method for a particular application? Could this combination of direct measurement, minimal interference, wide detection range, strong sensitivity to certain functional groups, and superior resolution explain why Raman spectroscopy continues to grow in importance across many scientific disciplines? What are RPBMN and SPBMN materials, and how do they differ in terms of synthesis? Could it be that RPMN is created by direct physical mixing of PB, Prussian blue type materials containing Mn superscript 2 and Ni superscript 2, while SBMN is synthesized by adding chemical inhibitors during the process?